Hey again, everyone. In this video, we're going to continue solving systems of equations algebraically, and again using the method called substitution. So you might be thinking, hey, these problems look familiar just like the last video. That's because these are from the last video. I wanted to compare what we're doing today to what we did last time. So what we're doing today is going to look more like this. So maybe they look a little bit more complicated. That's because there's going to be an extra step. But before we do that, I want to quickly review what we did last time. What is substitution? Substitution just means to replace. So what we did was, okay, in part A, we knew that y was equal to -2. So anywhere we saw a y, we could replace it with -2, which brings us down to a one variable equation, right? There's no more y because we put -2 in its place. And that was the goal of substitution. Okay, this was not so bad because in each of these problems, it told you what y was equal to. Here it told you y was equal to x minus 1. Here it told you what x was equal to. Same thing here, even though it was an equation. All you had to say is, okay, this is x. Let's pop it in for x here. The difference between that in this video is you might have to do an extra step because as you will notice, neither x or y is isolated here. Okay, so that's what makes this part 2 video a little bit trickier. So what you're going to need to do this time around is make sure you isolate, which means to get by itself, either x or y, doesn't matter whichever one's easier. I shouldn't say x and y, x or y before you do the substitution. So what do I mean by isolate? Let's focus on this word here. Isolate means to be by itself. So in the previous problems, you see in this equation, x was already by itself. So we didn't have to do anything because it was already alone. We know what x is equal to. Same thing with this. Y was already by itself. Y was equal to -2. You didn't have to do that step. But in this equation, we see none of these variables are by themselves. They're all, being added or subtracted to something. So step 1 in this second part video is going to be to isolate a variable. And it doesn't matter which variable you isolate. We're going to talk about what's easiest to do though, because in math, we always want to be the most efficient. Okay, so when you're looking to isolate a variable, you want to try and look for which variable is closest to being by itself. And that can be in either this equation or this equation, it does not matter. So I'm going to look at the 4 variables. Which one do you think is easiest to get by itself? Or which one's closest to being alone? Well, this 2y has a -2 in front of it. This -3x has a -3 in front of it. 5y has a -5 in front of it. But this x has no number in front of it, right? If there's no number, it's just a 1. So in my opinion, this x is going to be the easiest to get by itself. So that's what I'm going to show you how to do here. So I'm going to rewrite this equation, which you should do on your own paper. Okay, in order to get x by itself, we need to move away anything that's bothering the x. So what's bothering the x on the left side here is this -5y. So we're not necessarily solving an equation, we're just rearranging it so we can do a substitution. And in order to get rid of this -5y, we're going to move it to the right. Okay, but how do you move something in an equation? Right? If it was like 3x plus 1 equals 2, we would subtract 1 to undo addition to move it over to the right. Same idea, even though you're not solving. If this is a -5y, we're going to add 5y to both sides. And you might ask, Miss Mancini, why does that work? Well, we haven't done anything to x, so I'm just going to rewrite that real quick. But what is -5y plus 5y? If you flip it backwards, it's plus 5y minus 5y. Okay, those cancel each other out because they're inverses. It's like you have 5 y's and you take 5 y's away. Now you have no y's. So this would really be x plus 0, which x plus 0 is just x, which means x is by itself over here. But in an equation, whatever you do to one side, you have to do the other. So this equation now becomes -8 plus 5y. Okay, so let's kind of clean up what you see here to make it a little cleaner. Our original equation was x minus 5y equals -8. Our new equation is x equals -8 plus 5y. As you see, it still has an x, still has a 5y, but the 5y is on the other side. It still has a -8. Okay, so if we were looking at those two equations, we would say they were equivalent. Equivalent means that this equation and this equation say the same thing in a different order. Okay, but the reason why we need it in this order is now because x is isolated here. So if x is by itself, we can do the substitution step. So we know that x is equal to -8 plus 5y. That means anywhere you see an x, or x, you could substitute this new equation in to put it all in terms of y. Now we don't want to substitute for the first equation because, well, this here is the first equation. So we don't want to substitute it into itself. We want to substitute it in for the other equation. So first you're going to isolate either x or y before substituting. And then when you do the substitution, so this would be like a step 2, you are going to substitute, I spelled that wrong, S-U-B-S. Substitute into the other equation. I'm going to emphasize that word other equation. Not the one you rearranged, but the other one. So we're going to take x here and plug it in for the second equation's x. So it was -3 times x. Now x is -8 plus 5y. So instead of multiplying by x, we're multiplying by what x is equivalent to. Everything else stays the same, so it's still -2y. It was still equal to -10. And as you can see, just like the previous video, what that did for us is now we have an equation only with y's instead of dealing with x's and y's, which we can then clean up. So first I see the distributive property. So -3 times -8. Negative times a negative is a positive. 3 times 8 is 24. -3 times 5y. Well, it's negative times a positive, so it's negative. 3 times 5y is 15y. This stays the same because it's not being distributed with the 3, or the 3 isn't being distributed to the 2y, so it's still -2y. Just kind of writing everything else out the same. Okay, then I see we have like terms here, so let's combine those. Everything else will still stay the same. So you have -15y and you take away 2 more y's. So you're $15 in debt, you lose 2 more dollars, now you're $17 in debt. Okay, keep going. You want to isolate the y, right? Remember, in a system of equations, our goal is to solve for the unknown variable because that shows us where the intersection is of the two lines. So we want to get y by itself. We got to get rid of this first. Remember, we work in reverse PEMDAS. So first I'm going to do addition or subtraction. I'm going to move the numbers over to the right. So I want variables on one side, numbers on the other side. That's why I'm moving the 24 over to get numbers over there. 24 minus 24 is 0. Those cancel out. You're going to carry down the -17y. -10 minus 24. It's like you're $10 in debt and you lose 24 more dollars. Now you're more in debt, so you're -$34 in debt. Then it's -17 times y. How do you want to do multiplication? This is all a review, so I'm going quickly. Let me know if you have questions. But you want to do multiplication with division. So you get y equals, well, negative divided by negative is positive. 34 divided by 17 is 2. So we solved for our y variable. The only difference between this problem and the previous video is that you had to isolate the variable first with this step. Okay, we know that when we solve for y, that's only one of the variables here. So we're also going to need to solve for x. So what we do is we know now y is 2. We're going to substitute it in either for this equation or this equation to solve for x. Doesn't matter which one you choose. I'm just going to pick the one that looks simpler, which is the top one. It was 5 times y, but we know y is 2. Okay, and I need some space. I'm going to go over here. So x minus 5 times 2 is 10. Equals -8. Add 10 to both sides to get x by itself, because addition and subtraction undo each other, and that gives you 0. So you have 8 plus, or -8 plus 10, which is $8 in debt, but then you gain $10, so you're out of debt. Or you can do 10 minus 8, which is 2. So actually, x is 2 and y is 2, which you can also express your solution like a coordinate is 2, 2, where we write that as x, y. Okay, so that's pretty much the new step for today, is to isolate the variable. Okay, it doesn't matter if you isolate x or y, just remember I picked what's easiest. So let's kind of look at the next equation and see what we would do and talk it through. So it doesn't matter which equation you pick either. I can either isolate here or here. I can pick the x's or I can pick the y's. But which one looks closest to being alone? Well, this has a 3, so that's not close. This is a 4, this is an 8. It looks like this y is pretty close to being alone if I just move this 8x over here. Okay, how do I do that? Well, how do you undo a minus 8? Would be a plus 8x on both sides. Okay, so minus 8 plus 8, it's like you're $8 in debt. And then you gain $8, so now you're out of debt. You have no dollars, so that's 0. So y is by itself, and you have negative 11 plus 8x on this side. Okay, so again, we just rearranged the equation because now y is isolated. So what that means is you can take wherever you see y is equal to negative 11 plus 8x. So anywhere you see a y, we can plug negative 11 plus 8x in. However, remember you want to plug it into the other equation. You don't want to plug it into itself. So these two things are equivalent. You don't want to plug it in there. You want to plug it in here. So we're going to take that and do so. Since this is a review, I want you to try that on your own. So I want you to take negative 11 8x, substitute it in for y, clean it up, solve for y, then solve for x, and I'll come back with the answer. Okay, here's all my work, and my final answer is x is 1, y is negative 3. Take a look and see if you have any questions. Just to talk through a few key steps here. Remember we solved and we got y is equal to negative 11 plus 8x. So anywhere I saw a y, I could put this in its place, which was right here. So before it was 3x minus 4 times y. Now it would be 4 times negative 11 plus 8x, which is still equal to 15, right? These things stayed the same. It cleaned that up by distributing this minus 4, so that's plus 44 and minus 32x. The green highlights are me combining like terms. So 3x minus 32x is minus 29x here. And then I just solved by subtracting 44 for both sides. Kind of moved up here because I ran out of room. Divided both sides by negative 29 to get x equals 1. Okay, this work in blue over here is me substituting the fact that x is equal to 1 into x here. So it was 3 times x, but we know x is 1, so it's 3 times 1 minus 4y equals 15. And I solved and got y is negative 3. See how you did. If you did great, that's awesome. If you didn't, see where you made a mistake and what questions you might have so we can go over them. Make sure you write those in. I saw there was a mistake in letter G. This was supposed to be y, so I just fixed that. And just in time for you to try this on your own. I'm not going to give you any hints. Okay, so solve the system. Make sure you solve for x and y. I'll come back with the answer shortly, but no cheating. Okay, here's my work, color coordinated step by step for you. So moving left to right here, this is step 1, 2, and 3. So first I recognize y on the first equation was the closest to being isolated. So I rewrote that equation here, moved the 2x over by subtracting, and rewrote that equation as y is equal to negative 2x. Okay, then step 2, I plug that into the other equation, which is this one here. So it was 2x plus 2y, but now it's 2x plus 2 times what y was, which is negative 2x. All right, so I took that negative 2x, substituted in there. Okay, you see my work. 2 times negative 2x is negative 4x. Combine those like terms to get negative 2x. Divide both sides by negative 2, and you get x is negative 3, which is my final answer over here. Okay, last but not least, once you find x, you also need to step 3, solve for y. So it doesn't matter which equation you plug into. I just rewrote the first equation here. So it was y plus 2x. But we know x is now negative 3, so I made that substitution again. So it's y plus 2 times negative 3. 2 times negative 3 is minus 6, which is still equal to 0. Add 6 to both sides, you get y is equal to 6. And again, here's my final answer. Okay, so I went through that quickly. Please look through my work. If you did not get the same answer, see what mistake you made and what question you have. If you did get the same answer, that is great. If you didn't, no big deal. Let me know what you want to go over. And that is all I have for you, so have a great night.